thank you again, and at this point, I'll start taking questions. The first question is forensic DNA interpretation just Bayes? That's a useful way of looking at it. If the task is to arrive at some match statistic, then that can be broken down into two turns of Bayes' theorem, where first the full Bayes' theorem is used to infer genotypes from whatever data you have, mixtures, single source, kinship, and so on. And once you have those posterior probability distributions of separated out genotypes, then they can be put into a likelihood ratio, which is a two-state hypothesis and alternative form of Bayes' theorem, in order to calculate a likelihood ratio. The second question is, why do you want to separate out genotypes from families or from mixtures? There are ways of analyzing data where these data are not separated out and a likelihood ratio can be calculated, but the math is a lot more complex, and the methods tend not to look at all the variables that one can look at when doing a separation that uses all the data with a richer model. Really, the reason you want genotypes is that if you pull out genotypes of contributors, whether it's a contributor to a mixture or a contributor to a family, they can be uncertain and have probabilities. But once you have contributors, the math essentially becomes the math of single source DNA with some uncertainty. And now you're comparing one person's genotype to another person's genotype relative to a random genotype. The ideas, the concepts, the explanations, the words, the pictures, the way you explain things in court and answer questions, reduced to the simplicity of single source DNA we've enjoyed in forensics for over 10 years. The next question is, were all the figures in your talk generated using TrueAllele? All of the figures that involve genotypes, data, likelihood ratios, and so on were taken as TrueAllele screenshots. The next question is, has Cybergenetics used TrueAllele to identify victim remains or missing people? Yes, it has. About 10 years ago, we were asked by New York City to re-examine the World Trade Center DNA data. There were about 18,000 victim remains and 2,700 missing people, with both kinship information as well as personal effects that had mixture information. And in a large database, we inferred and separated out the genotypes of both victim remains and missing people as contributor genotypes, and the database compared them to compute likelihood ratio match statistics. There may be some other individual cases. That was sort of the larger scale database project that we did like that. The next question is, since TrueAllele is finding so much information, why do we need more than 13 CODIS loci for DNA analysis? Well, that's interesting. If you're using TrueAllele, you probably don't need more than 13 CODIS loci for DNA analysis because you're preserving enough of the information in your casework with mixtures and kinship, as well as in the database. However, if you're not trying to separate out the genotypes of mixtures or preserve as much information as you can from kinship data, and you're just producing lists of alleles, then you are losing a lot of information, and it may help to use more loci than just 13. The next question is, can a crime lab use TrueAllele for its paternity calculations? Yes, and some labs are starting to go down that path now. The next question is, how is dropout treated? I think the best answer to that question is the November webinar on degraded DNA and allele dropout. Spent about 15 minutes talking about how dropout is treated, and that might be a good starting point. The next question is, how long does it take for TrueAllele to infer a genotype in a family pedigree? The answer is that takes usually under 30 seconds. Now, because the process is part of a larger process, and a lab may have 16 processors, and there's administrative overhead in the system automatically getting a request, processing it, uploading it. The admin overload may add another minute or two, but the actual time to process a genotype is less than a minute. The next question is, for the LR calculation of a derived contributor of a mixture and the genotype distribution for a family member, wouldn't the likelihood ratio with respect to the sibling tend to be relatively uninformative? And the question is asked because siblings don't share alleles at every locus. The answer is yes and no. It would depend on how strong the inference is from the mixture. And a sibling is twice removed as opposed to a parent. So you probably would get less, you would definitely, on average, would get less information than with a parent or a child, but you can still get information. And it is relatively uninformative to making an inference from a parent, but it's more informative than making an inference with no information at all, that is, if you didn't have anything. It can be very low. It can be a little bit larger. It's not going to get probably much above 3 ban. And this would be an argument for using more loci or more kits if you had them, particularly if your mixture itself was producing an informative or a more informative genotype for an inferred contributor. Another question is kinship analysis a separate module of TrueAllele, or is it something that's built into the system? The answer is it's built into the system. If you have TrueAllele, you already have it. Cybergenetics is now working on preparing more extensive documentation, including this particular how TrueAllele works talk, but a lot of written documentation as well and application notes to provide more of a guide on how to use the kinship module for the sort of applications that we talked about today. Well, there are no further questions. I appreciate the questions that were asked and your time and attention. If you have questions about TrueAllele, feel free to email me at perlin@cybgen.com. If you haven't seen some of the previous webinars, or colleagues of yours haven't, please refer them to our webinar page. So have a happy holiday and a good new year, and I look forward to meeting with you again next month when we talk about genotype databases for DNA investigation. Thank you very much.